Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Well, it's been sadly, unfortunately, a bit of a stretch from the last video to today's video. As you can see, it's almost 2 weeks. Unfortunately, for the past 2 weeks, I couldn't actually do anything on the channel, add new videos. Just been a bit hectic at work, but nonetheless, as soon as we have a couple of minutes to spare, we will try to do some videos. So, if you can vaguely remember, we've been playing around the last couple of video tutorials using Sentinel images and with deriving various indices from our Sentinel images in order to identify and present urban areas or build-up areas. So that's what we want to do, is we want to use our Sentinel images and the index methodologies to see, okay, can we isolate build-up or urban areas within our region of interest? And we've played around with a whole number of indices, and they basically are just using different bands and different band combinations or equations to try to isolate these urban or build-up areas. And that's what we've been doing for the last number of video tutorials. I think about 6 or 7 video tutorials. And what we basically generalized, or what it seems like, is that there's no one particular index that captures build-up or urban areas particularly well within my region of interest. Now remember, this may or may not be true for your region of interest, because each region of interest are very, very different, and therefore the indexes might behave or might generate results which is not very good in my region of interest, but may actually be very good for your region of interest. So just because it doesn't work for me or my region of interest doesn't mean it doesn't work for you. And if you go through the video tutorials, you'll find out the big problem is urban soil, bare soil. That's my big issue, is bare soil. The more bare soil you have, the more complex or more difficult it becomes. If you have no bare soils, then I think you're in for a nice time. Then I think you are made. Then I don't think you have too much to worry about. But if you're like me, bare soils, then you are, yeah, I wouldn't say screwed, but you have a problem. Now again, here I'm using summer periods, because that's when most of the bare soil is present. I'm sure if I use winter periods, then it will significantly improve the outcomes or the results of these indexes. But let's forge ahead. So what I want to do now is, within our, if we go to our script, then within our script, there was 2 particular indices that caught my attention. There's 2 particular indexes that caught my attention. And so what I want to do is to work with these 2 indexes and say, if we combine them, rather than use them as individual or separate indexes, if we combine them, can we harness the benefit of each to generate, what we want to achieve? So that's what I want to play around with in this video tutorial. So say, okay, we have these 2 indexes. They have strengths and weaknesses. If we combine them, can we double up on the strengths while eliminating their weaknesses? That's what I want to have a look. And the first one that I'm curious about is this build-up area extraction. Sorry, it's not. It's the it's this one here. The band ratio for build-up area. That's the first one that I'm interested in, is the band ratio for build-up area. If you go through the video tutorials, you'll find the one that focuses on this particular index. You will see that this one gives us the best results in terms of distinguishing between build-up areas and bare soils. This is the one that seemingly presents or differentiate between the two the best. Okay. And you can clearly see this. This is in red, the build-up areas. And then you'll see where there's supposed to be bare soil or where there's bare soil, like this particular area here, it differentiates quite significantly. So this one is interesting because it allows us to differentiate. So that's a very big strong point, a benefit of this particular index. So the band ratio for build-up, its big benefit is that it can differentiate between build-up and bare soils, or it differentiates the best. Let me not say it can differentiate, it differentiates the best. Okay, so that is quite a neat one. So that's a big a benefit. Okay, that's a big benefit of this one. Its weak point is that it doesn't present build-up area that nicely. Okay, so there's a lot of build-up here. In this area here that is not presented. So its weak point is that it's not great at presenting the full picture of the build-up area. The full build-up area, it's a bit weak on that. So its benefit, it can differentiate between build-up and bare soil. Its weakness is that it cannot capture the entirety of the build-up. So that's its main weakness and benefit. Okay, so that is the band ratio for build-up. Okay, so I want to have that one in my memory. I want to use up. It's the band ratio for build-up. So that's important for its benefit, but we want to minimize its weakness. The next one that I'm interested in is this one called the build-up area extraction index. The build-up area extraction index. So this one is of particular interest for the following reason. If I highlight this now, let's quickly go there. You can see its weakness. Okay, so let's start with its weakness first. Its weakness is that it struggles to differentiate between build-up and bare soil. Okay, so where the previous one, its benefit is that it can differentiate. This one's weakness is that it struggles to differentiate. Okay, so it has opposite. Yeah, it has the opposite weakness of the benefit of the previous one. However, look at its ability to identify build-up areas. It's much better than the previous one. So where the previous index, its weakness is its inability to properly capture build-up area, this one's benefit is that it can do that. So it seems to me, if you catch my thinking here, it seems to me that the two should cancel out. And therefore, I should then sit with the ideal situation. In theory, that seems plausible to me. It seems logic to me. That if we can combine these two, combine the best of these two, I mean, to differentiate and capture build-up areas. That's the ideal index. Okay, that's the ideal index. So we need to eliminate the two weaknesses and add the two benefits. Then we're in the best position. Now, how do I do that? How do we combine this so that we add the two benefits and subtract the two weaknesses? So we want to eliminate the weakness of the build ratio, the build ratio for build-up. I want to eliminate this one's weakness, this band ratio for build-up, which is that it doesn't capture build-up properly. I want to eliminate that, but I want to keep the weakness. It differentiate. And then with this one, the build-up area index, I want to keep the benefit, which is it captures build-up, but I want to eliminate its weakness, which is it doesn't differentiate. I hope this makes sense to you. I'm trying to rationalize this in my mind. To say I've got these two indexes, can we combine them? And how do we combine them so that we eliminate the weaknesses but keep the benefits? So how do we do that? Okay. And so what I've initially said is, okay, let's subtract these two from one another. Let's subtract the two from one another. And it doesn't really matter if you subtract this one from that one or that one from this one. I don't think that's really the issue. It is whether by subtracting we achieve our objective. Whether by subtracting do we achieve our objective. My mind says for me yes, but we have to look. What I think it's important is let's get the numbers. Let's get the numbers of each index and then let's see what we're going to do. So I'm going to identify, okay, we need to wait again for these things to load. By the way, thank you to one of my subscribers that indicated that I must add this comma false in my add layer and then it will not automatically display. You see, so it doesn't automatically display. Okay, so how do I do this? By adding this comma false in my add layer after I have the name of the layer. Then I just say comma false, then it won't automatically display the layer. Okay, anyway, so let's go to inspector. So I'm going to say here's a build-up area. A build-up area, and I want to calculate I want to get the numbers for the two individual indexes so that I can see what I'm working with. And the problem is, let's go to house. Okay, let's go to this area. I think this is going to be a better area to work with. Come on. Okay. Yeah, here we go. I just want to make sure I'm selecting the a build-up location, a build-up area. Okay, so that's why I want to zoom in a little bit to make sure I am. So let's go to satellite. Okay, so I want to click on this one here. Okay, so let's click on that one. What is that one here? Let's quickly. So I want to click on this. This is all build up. So just to make sure that we are on the right one. And band build up. Okay, so I'm going to click on, let's say, that position there. Okay, so that is a build-up area. So let's go to my two indexes. Okay, there is the band build-up area. So that is 0.6. Okay, and the extraction index is 0.4. Okay, so that should be clear. Okay, so the build-up extraction is the band build-up area, the band ratio for build-up. Sorry, band build-up area. Come on, band build-up area. Yes, that's 0.6, and extraction is 0.4. Okay, so let's identify open soil. There we go. And let's see what that looks like. What's the numbers there? Okay. Okay, so let's just click on one there. So let's have a look what the numbers look like. Okay, so that's base soil, eh? That's base soil. Aye. Sorry about that. It's like taking a bit of a time. Okay, so let's have a look and see where is it. Okay, so there is the band buildup. So that gives you 0.56. Band buildup 0.56 and extraction 0.4, which is very similar to the previous. You can see it's the band buildup is very similar to the base to the buildup areas, where here there's a difference. It was 0.6, this is 0.56. So that's a difference of 0.04. in the index values between build-up and, so I should, if I subtract, get a value of 0.04, whereas if I subtract using the build-up extraction, I should get a value of plus minus 0. Okay, so let's quickly just go back. It's difficult to know these places, unfortunately. Let's go back here. I think it was this place here. Let's click on that one. Just want to confirm. Just want to confirm that quickly. Where is it? It just takes its time. Sorry. Okay, you see there is the build-up area. So that's a bit bigger, 0.4, which is same as that other one. So there is a bit, but you can see the difference between the build-up extraction and the bare soils are very little, whereas the band has a bigger difference. Okay, so if I subtract the two, if I subtract this one and that, so if I subtract 0. So I should get 0.2 and I should get 0.16. So if I subtract this area here, and I subtract the two, 0.77 and 0.45, okay, let's say in this case, I should get 0. What's it? 232. There we go. I should get 0.32. Whereas, okay, so let's make it 0.32. So that's the difference in this case for the build-up area between the two indexes. If I go to the bare soil, let's see what the difference looks like there. Let's remember this is this one, plus minus there. Okay, and what's the difference there? What we want to calculate is the difference between the two indexes for bare soil. Okay, so let's have a look and see what that comes out. So it is 0.56 and 0.4, so that gives me 0.15. Let's say 0.16. So it's important. So the difference between the two when it comes to bare soils are quite small, with the difference between the two in terms of build-up area is quite large. Okay, so the similarity or the two indexes is quite similar in terms of its measurement of bare soil. However, its measurement of build-up is much bigger. The difference between the two is much bigger. So if I subtract the two, then higher numbers should indicate build-up areas, where smaller numbers should indicate bare soils. Okay, so when I subtract the two, remember I start with the BRBA. Which one is the BRBA? The BRBA. Okay, so I have it the small one, build-up area index. Now I've got the big one, the larger value, 0.56 minus the small value. So they should be positive. Okay, so the numbers should be positive when I subtract them. Okay, so let's have a look and see. I go back to my build-up area index, which is here, this one here. Okay, so if I subtract them, okay, and I get build-up area. So I create a new variable, which is called build-up area, which is subtracting the two indexes. I give it a name, I clip it to my region of interest, then I generate its minimum and maximum values. Okay, which, as I said, in this case would be positive, and I've got it 0.1 to 1. There's my, and I display it. Okay, so that's how it looks. And I display it. Okay, so let's quickly wait. And there it is. You'll see it highlights build-up areas as red and orange. Let's go and have a look and see in our bare soils. Let me just take that one out. Let's go to our bare soil area, which is this area here. Eventually, we'll get there. And you can see it differentiates and it presents the build-up areas quite nicely. Okay, so it does still have problems in that this bare soils here. So it still have problems. So what we can do is we can try to eliminate the river and its associated bare soil because it does skew it a little bit. So what we need to do is maybe we have to subtract this as well. But let's first have a look at our results. If we subtract these two, then we keep the benefit that it differentiates. Okay, let's just quickly, and we can play, I'm going to play around with it. So you can see it differentiates quite nicely between build-up and bare soils. It does differentiate. And it highlights, not perfectly, but not too bad. So let's say we compare it to its two parts. So let's go to the build-up area. Okay. You'll see if I compare it, it does highlight the build-up areas better than it. Okay, so it does highlight the build-up area better. And it differentiates. So somehow, we know how, we were able to, no, not perfectly, by no means, I'm not saying this is perfect, but it gives us some idea. It gives us some room to think about it and still expand on this. Is to say we have these two indexes, they have the benefit of this one is this one's weakness, and that one's benefit is this one's weakness. So how do I keep the two benefits, but I eliminate the two weaknesses? Let's subtract the two. Let's subtract the two. And this is the result of that. So hopefully in this case, we've kept the benefits of both, but we eliminated the weaknesses of them. And it does seem to a large degree, it does seem to do that. Although it's by no means perfect, in that it still does have some bare soils, it did differentiate without losing its ability to indicate, you can see where's this down now, its ability to, okay, let's have a look and see, here is some, to highlight build-up areas. Let's just see, it does take a bit of time, my apologies. You see, it does, it does indicate these build-up areas, which additionally is very, very difficult to. Let's look at that one there. Band build, see if, yeah. So, is this good? Is this good? Is it good? It does hold promises, but you can see there's still places where it struggles. Huh? There's still places where it is not ideal. So maybe, but what we can do is now we can play around with this formula. We can play around with this formula. So let's say we want to amplify one of them, then we can multiply it and subtract it. We can potentially divide it, the two with one another, and try it again. So we've now subtracted. Okay, so let's understand the subtract and see what that looks like. Let's look at this place. Now what I want to do now is to say, listen, let's not subtract, let's divide it. Would that improve it? Will that improve it? I don't know. If I change it to divide, let's run it. The only way we're going to know this is by actually playing around with it. And that's the beauty of it. We can now play around with it and see what the results is, where the results are better or not. Now, when I divide, we most probably will have to change the minimum. You see now it's going to give white. So what we need to do is we need to get build up area, the console. We need to go to invalid We need to get build up, so it's 2. Minimum value is, let's make it 1. Minimum value is 1.0. And maximum value, let's make it 2.7. 2.7. Okay, so let's run it again. Yeah, so please remember, every time we change the formula, we will have to change the visualization parameters. Otherwise, it's not gonna work. Let's see again what it does. Ooh, that's not working. So that's for sure not gonna work. It does. Let's go in here. You see divide. That's not gonna work that well. Although it highlights the build-up areas, well, maybe not. We need to differentiate between the yellow. So if we do the orange, because that's an orange color, let's say we do that. Let's make that blue and make that orange. Run it again. Let's see. Who knows? We may be up to a winner here. We may have discovered something very, very new together. Who knows? Trial and error. Let's quickly go there. This is quite exciting. This is quite exciting work. So let's see. It makes you think. And that's the purpose of this. Look at that. This doesn't look too bad. Look how well it identifies the urban area, and it just eliminates the bare soils. It does still have some problems here. You can see there, and here and there. You can see some problems there. But look at how well it captures this urban area, this particular urban area. And it doesn't have the bare soils. This blue is, yeah. It does have here as well a little bit of the reddish, but you can see the dark red. We can work on this to eliminate this red, and that would be by playing around here. But this looks a little bit better. The orange is very, very in your face, so to speak. You can see it identifies Porterville, which is a small town. This actually, there's some small problems, but this doesn't look too bad. This is something that we remember to save. Something that we can play around with. This is something that we can play around with to define it. To define it. It's not the end product, but there seems to be quite a bit of promise. It does capture build-up areas quite well. It does to a large degree differentiate quite well between build-up and bare soils. How's that? So let's quickly see if we play around with its visualization parameters. We go to this one, stretch, change the minimum and maximum values a bit. Ooh. Nope. Now, that's not gonna work. Stretch it. So all I'm doing is we're changing the range, huh? We're changing the min-max. That's all we're doing by using these. Ooh, nope. No, 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 no. That doesn't seem to work. Ooh, nope, 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 nope. You see the maximum value is 12, and we have it as 2.7. So that's not going to work. Nope. 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 It's not working at all. So we're going to resolve if I run it again. Let's run it again. We're going to go back to, I would play around with the color scheme a little bit, etc., etc. But I think in general, this works. Well, it's a starting point. Let me put it that way. It's a starting point. So I'm quite optimistic about this. So divide seems to be a better option than subtract. Divide seems to be a better option than subtract. So yeah, I like this. This seems, on first sight, we can identify urban areas. And if we drill down, we can identify it even better. And um, good news is that it differentiates, let's say, 90% of the time between bare soils and urban areas, which is in fact not too bad. We have these areas, but it would be nice now to play this in the winter. So maybe that's going to be my next video tutorials, is to change the images from summer to winter and then rerun it and see what that looks like. So I'm going to copy this, and I'm going to create another tutorial, call it tutorial 2 or whatever, and I'm going to just change it to winter and then run it and see how the summer and the winter indexes compare. Ladies and gents, thank you very much. I hope you enjoyed this video tutorial. Something spontaneous, something different. Not much Google Earth work, to be very honest. But I think the idea also with channel is not to just show you how to code, but also to think about these things and come up with your own ideas and suggestions and things, because the code is there. We can just then use the code and play around with it to come up or to develop new ideas for your particular situation. If your situation is such that these indexes work for your region of interest, you don't have to worry about this. But in my case, it doesn't work for me. So I think this. So it's also about applying this rather than just to do this. So I hope that that helps, and it's interesting. It gives you some ideas. Okay, and then yeah, I will start with a new one. Hopefully, there will be more frequent uploads and not this long periods of time. I should be able to do that. Thank you much for your participation, and thanks for following me. Please, boys and girls, please subscribe. I know many of you have subscribed, but for those that haven't subscribed, please do so. I need to reach the 300 soon so that our target is 1,000 subscribers. We need to get to the 1,000 level as soon as possible. If you have any comments, suggestions, please let me know. Happy to respond to it. And I'll see you on the other side.